So I'm going to try and fix this thing today. Well, we'll try and figure out what's going on with it at least and have a poke around. We may not get it finished today, but it might be multiple videos I have to do. We'll see what happens, but it's still sealed in the back here. Still got a sticker over that, so it actually says property of national semiconductor, so that's interesting. Basically, I'm getting some error codes on the screen. If you didn't see the previous video I did not long ago, a little teaser video, it showed the full codes it's giving. It's giving a boot up test failure of 0726 and 0731. It could be RAM, apparently. It could be power supplies, potentially. I don't know. When I first looked at this, I thought it was a power supply problem. We'll pull it apart and we'll see what we're dealing with. I mean, I always suspect power supplies first. I mean, my general philosophy is, if you've got a problem with an instrument, recap it. First thing, replace all the capacitors. Make sure the power supplies are good. Because 99% of the time, that will solve the problem. And the other 1% of the time, it would have been greatly aggravating the problem. And it may have caused a further failure from bad power supplies. So the power supplies are always something you attack first. Always. At the very least, you inspect them and make sure it looks kind of alright. Because you never know, someone else might have already been there and replaced all the caps and done that job for you. It's happened to me before. I've got an instrument and it's been done already. So, you know, you never quite know. But my first suspicion is always power supplies. You rule those out and make sure they're good. And not just the main power supplies, but you also got sub-supplies and other circuit boards. A lot of times boards would have their own little sub-rails on them. Might be a little 5-volt rail or something like that, which is split off from the main supply. Always suspect those as well. Make sure that you've got any capacitors and those circuits, that those are done as well. Obviously checking for tantalum caps which are blown up, you know, any black stains on the circuit boards, that kind of thing. Previous work. The fact it's still sealed means it's probably failed and no one's touched it, which is a good thing. If someone else has already been playing with it after it's failed, you don't quite know for sure what you're dealing with, but if it's failed and it's not been touched, you're a bit more confidence. Okay, so whilst I'm recording this video, I'm also doing a live stream, and Willem, who's a member, supporter of the channel, he pointed out the pages that I was looking at previously, so I showed he'd seen that video. It does indeed reference power supply in that section. So it's got conflicting information in a way, like it says test 0 could be power supply, but also says test 0726 and stuff is RAM failure, so it could be either, really. I'm hoping it's power supply. RAM would be a bit of a pain to deal with. This is a bit sticky. Come on, move. Oh, that's going to be a problem. Ooh, it's jammed. This has all been twisted a little bit as well, it's not helping. Here we go. Because it's bent a little bit, I have to try and sort that out. It's been bent one way, so I need to try and straighten it. Very tight. Oh, the internal shields are still there, that's always a good sign. Right, so you've got CRT over here. Now this is dangerous. Now this has been powered off for a few days, but that doesn't mean it's safe. There could still be high voltages. Now CRTs can act like a capacitor themselves and actually hold a charge. And there's also some massive caps right here. There's likely to still be high voltage in this area, so this is something I've got to try and avoid touching anything around. I'm going to be working in this area initially, which is power supply. I might just pull cards out, inspect all the cards, see if I can see anything dodgy on any of the cards. I'll start over here. I'm going to start on the actual brain of it first, just for inspection, and then we'll pull the cards out, have a quick look at them all, and then we'll work our way back. And then the intention then is that by the time we get to the power supply, I should have found nothing over here, fingers crossed, and then I can work on the power supply section. Because there's no point doing the power supply, then forgetting to check further, and then finding you've got a fault on here and the power supply blows it out further. It could be that you get a fault over here which then blows, which damages the power supply. Or vice versa, obviously, but I want to check over here first. Little posi drives, look at it. You need to have washers on, so don't drop the washers if you're doing this yourself. Don't have to be trying to get those back out of the chassis, floating around from somewhere. This isn't actually the right screwdriver for this, but it's a Phillips screwdriver. These are posi drive screws. You can tell a posi drive screw because it's got the lines on it. I don't know if you can see it on camera here or not. Let's try and show you. So you've got those extra lines that go away from the centre, so you've got them all across, and you've got the X that goes across them, that means posi drive. In case you didn't know that. I've done very little research on this thing. I'm just basically poking around, going to see what I can find. Spin it around. The video I watched from MJ Morton, he had an issue on this card here, the yellow tab card. with a tunable capacitor just here. He couldn't get that capacitor tuned correctly. He had a lot of corrosion and stuff like that on it apparently. Bit of oxidisation. I mean, I'm seeing a little bit on this, not looking too bad. It doesn't look as bad as the one he had actually, so hopefully it's not a problem of mine. It's to do with the noise floor adjustment. We'll worry about it if I get to it. So let's pull these cards out. Now this does have diagnostic LEDs inside it as well, so when you power it up you do get LEDs that light up and tell you things it has detected. Once I've gone through the boards and done any rectifications I find, then I will look for those LEDs, see what those are saying as well. Right now I haven't done that. I've only powered up with the case on. It's the first time I've taken the case off. Let's see if we can figure out how to get this board out. Yeah, it's just that one connector there. Let's pop that off. It's a SMB connector. It's very tight. I'm not quite sure. I didn't give much room to actually get that connector off there. There we go. Okay, touch the desk, put it, then put it down. Right, this is covered in axial tents. I'm looking for the bead type axial tents, see if I've got any of those which are blown. Anti-static, super important. Make sure you touch anti-static surfaces before you pick things up, and make sure you're not using this to bridge across between you and the surface, unless you've already touched it. So we've got a whole bunch of these spiral caps on there. Now generally they're good. I don't really come across many problems with them. They're usually pretty good. So I'm just looking for any tantalums. I'm not seeing anything on here, so that's a good thing. So like just here, that looks like an actual tantalum, just there. But these are probably tantalums too, you know, they quite commonly are. But there's nothing there which looks burnt. Check this side. There's some tarnishing on these connectors. So these are slightly tarnished. So I will actually give these a polish up before I put the board back in again. Maybe put some deoxit on it. Checking for any rework. That board looks factory. Can't see any signs of rework on that board. That looks mint. That's good. That's a good sign. So I just noticed this top cover here was rattling around, so I just pulled this off. You can actually, this is a slotted hole, so you can actually lift this cable out, which would have made getting that board out a lot easier. Anyway, there we go. But this board here also needs to come out, but it's got a comment on the top here saying remove the input cable before you take the board out. So the input cable's down the side in this hole down there somewhere. I can barely see it. It may be you have to take the bottom cover off and then you can access it from here, because it is about there. That's probably the way to do it, is take the bottom cover off and get to it. So we'll do this board first and we'll come back and pull this one apart. Alright, so what I'm going to do, I've got my fiberglass brush here. I'm just going to quickly just run along these edges on this edge connector here, take the tarnishing off. I'm going to put some deoxit gold on it just to put a coating on that, and when I plug it back in again that should help to remove tarnishing and protect this and also the connector, because obviously I can't clean the connector. Putting the board in and out a couple of times will help to clean it a little bit anyway, but with a bit of deoxit on there that should help do the job. Now these are gold plated, so you don't want to go to town with this thing, you just want to gently do it and just get the oxidization off. Now sometimes, you know, that's basically what it needs. So what I'm actually going to do is just going to run down each one like this until I see it being shiny. So it's a bit tedious, but the amount of things I've actually fixed just by giving the gold plate a bit of a wipe with this. Now, because you do get tarnishing on gold plate, it's not perfect. It resists tarnishing, it's not completely tarnish proof. The amount of times I've fixed things just by giving these a bit of a polish up and cleaning them, it's quite surprising. The same on this side. Again, you don't want to go too much with this because you don't want to damage the gold plate, you don't want to take the gold plating off, but you do want to get that tarnishing off. 2 swipes seems to basically do it. Let's give us a bit of a spray with this. Don't actually need that much. Just gonna wipe it along there. Okay, now let's drop that card back in, and hopefully the deoxit that's on it will help to clean it. Folded that over, and we'll push this in. Just rock it in. Hopefully. There we go. I'm going to pop it back out again. And push it in again. And let's do that a couple of times just to help clean the actual connector itself as well. So that's that board there, inspected and cleaned up a little bit. I'm going to take this bottom cover off and see if I can get to this connector to get this board here out. So I'm going to remove the bottom panel. It's the first time I come across this particular setup, is where the voltage selector is on the bottom of the unit. So it's over here. That's what this bit is. Voltage selection switches. Instead of being on the rear panel, I guess they didn't have much space and thought, well, you don't really need to access them once it's set, so underneath is fine. And it's just the first time I come across them being here. They're really nice circuit boards. Here's all the voltage regulators down this side. This is power supply section, obviously, in this section here. All the regulators are actually marked. They're using HP part numbers, but they're actually marked, so you know, it gives you something to go by at least. And it's got this plastic sheet on the bottom here to protect you as well, which is a good thing. So there's the connector just over here, which I've got to pop out first before I can lift out this board. So let's do that. Getting it back in again can be interesting. Tight. There we go. Does have some holes here to grab hold of though. Let's do that, shall we? There we go. Haven't missed anything, hopefully. Yep, sweet as, that's out. So yes, attenuator adjust. So it's attenuator board. Okay, so look at this board. So apparently this is attenuator section in here. So input must go in, attenuated, then it's processed in something on here somehow. So I suspect it, see if there's anything obvious here about being bad. It's actually looking pretty good. It looks like it's got conformal coating everywhere as well. It's got something anyway, some kind of coating on it. So I'm not going to take this cover off. Oh, maybe I should. Maybe I should see what's in there. Just to be absolutely sure there's nothing in there which is blown up. That's a long screw, it must go through to the other side. It does. Okay. Hopefully removing the cover doesn't upset the calibration stuff. Probably shouldn't. I don't think it's going to be that precise anyway. It's low frequency, it's not like it's high frequency stuff where it matters that much. Less likely to be a problem on low frequency. Look at the back of the board yet as well and make sure there's no rework signs on the back of the board. Okay, so what we've got in here. A few trimmers, bunch of read relays. Nothing of concern, it all looks fine. Visually it looks good. Actually, well, I've got that off, I might as well just look at the back of the board as well. There's some resoldering around here, and there, so flux residue. Read relays. That's a relay there, those are relays there. So someone's resoldered those relays at some point. Maybe they've been replaced. Probably not a big deal. So here you can see the flux residue around that read relay there. Can't see it there. Alright, so that's the kind of thing I'm looking out for on the board to see if there's any rework. So it looks like two read relays have been reworked or replaced. Yes, maybe just there, there's a bit more maybe. The conformal coating is actually quite good in this way because it actually helps to highlight when something's been reworked. That board looks generally okay apart from those read relays. So maybe there's a relay problem. Who knows? It could be they've already been repaired. So I'm going to do the same thing again on this. I'm not going to show you, but I'm just going to clean this connector up again. So every board I take out, I'm going to clean up the edge connector. Because say, the amount of times I've actually fixed gear just by cleaning the connectors up is quite surprising. So I just realised, I actually noticed this as well when I was inspecting the board. On the back here, there's a pull tab. I could have used that to get the board out. You know, instead of levering those corners up, I could have used the pull tab. Although, these tabs, I try to be really careful with them when they're old like this, because this board is very stiff to get in and out, and it's likely that when you pull this tab it will break. So what I would have probably done, actually, I probably would have been pulling that tab and levering up at the same time. Right, take the stress off it, because I mean, when these tabs are new they're probably fine, but plastics get brittle with age, and heat especially. So if they've been in a warm environment, it accelerates that process and they get brittle. So I'm just reseating the car like I did with that one, just to make sure that it's had a chance to clean the actual connector up as well. The actual socket. So let's do it a couple of times. Alright, so that's that done. Now I'm going to pop this cable back down. Look how much easier that was, and now I've got the cover off. Yeah. It's not a very tight fit on there. It might keep falling off, we'll see. Let's put this connector on before I forget, because I've got a reason to suspect I'm going to leave it alone. Right, that's that and done. Next board. Oh, that's tight. Don't break. Oh. I'm always really nervous about these because I've had these tabs break off before when you got a really tight board. I've had them break, so I'm really nervous about them snapping off. I've had to 3D print them before, so I actually do have a 3D print design file for these HP levers. So I can replace them if they break, but I'd rather not break them off in the first place. So what I should actually do is label on here what these boards are, so when I'm trying to troubleshoot, it'll be easier to figure out what's going on, because I'll know which board's which, because right now I don't actually have a clue, I'm just looking at them. This side looks fine, but there does seem to be some kind of residue on the board here. Like something's got on there at some point. Maybe some old flux residue has been washed off or something, I'm sure. This one's not as pristine as the other boards were. It's still pretty good. I don't see any rework, so maybe it's fine. So yes, an awful lot of digital going on here. So we've got some test headers on there as well. It's coming upside down. Now this might be the RAM board, is it? Is this the one I'm thinking of, the RAM board? It could be this one. Need to figure out which board's got the RAM on it, so I can watch out for that particular chip which I was worried about. But this side's looking fine, there's nothing really untoward here. We'll clean the connectors up. Let's put out the next board. Now I've reseated that one in to clean all that one up. This one's coming out a little bit easier. Let's have a look. Anything bad on here? A bit of dust in this area here. Get that wipe off. But otherwise looking alright. So it's looking basically fine. So just a little bit of dust. Check the other side. No signs of rework. This board looks pristine. Excellent. I'll clean this one up, put it back in. Put out the yellow card. Now the orange one's back in. Oh, that's tight. Okay. Now this is the card that with this trimmer here. I'm hoping I don't have the same problem in this one. Again, this seems to be quite common. The ones I've seen, they're never fully populated, which is quite interesting. But look at this massive IC here. Look at the size of this beast. Wow, that's huge. That is probably the biggest IC you've ever seen. So I was inspecting the card now, and this looks fine. The back of the board doesn't like any rework. The front of the board looks fine as well. I can't see anything wrong here. It looks fine. So I was going to clean the connectors up, just like I did the other times, and put it back in. Now let's pull the green board out. Now the yellow one's all been cleaned up and put in. When you pull boards out, always pull them out gently, in case there's a cable connected off it, doesn't it? Like. This one looks interesting. What are your problems over here? So this board here has got some residue on this connector here. It actually feels slightly sticky as well, like maybe it's some flux residue or something. Or something's been spilt on it maybe. Curious. But you can see some signs around here as well. A bit of dust up there. Anyway, this one doesn't look too bad. I'm just going to clean it up, put it back together. Alright, let's pull the next board out here. This feels pretty tight. Oh, I can feel the clips bending. It's never a good sign. Let's do one end at a time and try and pull the middle of the board at the same time. That works better. Sometimes it helps. There we go. It's actually binding in there. It's actually quite tight in there. Oh, that's interesting. Why? Ah, that's why. Look, it's got this finger on the back of it. That's why it's tight. It's rubbing on the back. Extra shielding. Oh, the back of the board looks... Oh, that's interesting. This chip has been reworked over here. Looks okay apart from that. And that soldering doesn't look that good, to be honest. That looks like it needs doing again. You see that? The solder's just not really there. Barely soldered, those pins. Oh, come on. So I reckon that's something I should do, is actually resolder those. Those look dodgy. See that? There's like Nah. Yeah, I'm happy with that soldering. That is redoing. Yeah, sound effects. So I've got my iron set to 300 degrees. Got this massive tip on it there. We shall see how this goes. Let's use silver solder. Use the good stuff. Yeah, it's some pretty awful soldering. I'm really surprised, you know, someone's working on something like this. I thought the soldering better than that. Someone's repairing something like this. It's a bit of high quality. Higher skill set, I should say. Anyway, here we go once I've finished. At least then we know that this chip will be working properly. I mean, is this a case someone's actually come around and replaced this chip, or have they taken it out and put it back in again? I don't know. Also inspect it once I've done this and cleaned it up and make sure that there's no damaged traces and that sort of stuff. There could be. There's a lot of flux on here. Anyway, what was there was no good. Let's have a close look at this. See if I solved it or not. Yeah, I think so. Get the thing in focus for you. Yeah, certainly better than what was there. Okay, let's check the other side. So this chip looks different to the rest. So it's been replaced. It's not an original HP part number, so that chip has been replaced. I'm just trying to have a close look at the actual traces and make sure they look alright. See, there's flux on this side as well, and it's cleaning too. See, there's pins there, it's not good. Get that off. Last thing you want is flux leading through the circuit board. Don't need through the traces, because you don't know what flux they use, or what, whether it's an acid flux or something like that. You just don't know. So you might find that what's on there is actually could be corrosive. Hopefully I haven't used an acid flux, but it's certainly possible. So best to just clean it off and do what I can to get rid of it. But the fact that this thing was still sealed, it had the seals on it still. So this repair was obviously successful, because otherwise it would have been sealed up and recalibrated after that point. Alright, so it was obviously working, but it wasn't great, was it? It could have failed again at some point in the future. Maybe that's what's wrong with it now. Yeah, it's looking 10 times better. Checking the rest of the board, because it did distract me away from looking at the rest of it. But it's looking fine. So I think we're good now. Put it back in.